All right, folks, I'm going to get started. Welcome back, everybody. Welcome back to Econ 160. It's the start of the second week. We survived the first week of the semester. Congratulations. Um, and now we are in the second week. We started on some material last time. We're going to continue again today. I hope everybody had a good weekend. As far as like all the stuff going on with our administration and how they're treating Muslims, it's unfortunate. If you are Muslim, I apologize on behalf of all the American people, and also if for whatever reason, you're feeling bad and you have feelings that you can't deal with too well, like there's counseling services on the university. You can come talk to me. You can talk to your other professors. Just talk to somebody about it. Like you have to take solace in the fact that sometimes because of the way that our political system works, you're going to get some ups and downs with respect to like our liberties and the approaches that government takes to our lives, and you can't take it personally, and you have to just kind of accept that there's people out there that might not like you and might treat you bad, but then there's a lot of other people that really do respect you, treat you well, and don't feel the same way about you as these particular individuals. So you got to focus on the good versus the bad. But again, like if you're feeling stuff, make sure you talk to people about it. Don't let things bottle up and just fester, because that's when things can ultimately spiral out of control. All right, to those of you that are trying to get into the class is still currently full. There are no available spots open, but you have to keep coming to the class, and you have to be here at the start of the class and until the very end, and then sign in to just be in the running for a permission number as slots potentially open up. So right now I have 10 people on here, and the order you're in is the order that you were in the wait list. So Christian Escobar is first, Olivier Arani Top is second, Maurizio Rosas is third, Stephanie Calabrese is fourth, Vanessa Alvarado is fifth, Grant Rosenberg is sixth, Sharif Martin is seven, William Cruz is eight, Yauchi Lin is nine, and Liana Amirian is 10. Maybe some of those people didn't show up today, so they'll be out of the running, and then that'll narrow the amount of people waiting. But again, it has to do with slots opening up, so people have to drop out for you to get in. It's up to you to decide if you want to keep trying. There's 2 weeks worth of time in which that could happen, so you never know. If you're number one, you're likely to get into the class, so you're going to be all right, but you have to keep coming until that happens. And if you're kind of at the top of the list, your chances are good, ish. If you're in the middle, a little bit less, but who knows? And then if you're at the bottom, tough to say. Up to you to decide. You can decide whatever you want to do, but those are the circumstances you face, and that is as much as I'm going to say about that right now. If you have any more questions about it, come talk to me at the end of class. Are there any questions about anything you'd like me to address before I start lecturing? All right. So everybody has a seat today, which is good. People are already starting to get into that comfortable pattern of like, I'm not going to go to class all the time. I don't need to go to class all the time. That's a bad approach. So don't fall into that pattern. Only miss class when you have to miss class. Again, class is like you going through the material with me once. And a class like this, you have to go through the material several times in order to do well in it. So if you're coming to class, you're at least going through it once. Ideally, you're taking notes. You go home, you listen to the lecture again, maybe read the chapter, fill in the gaps in the notes, stuff that you didn't quite understand too well or maybe missed during the lecture. And then at some point, early on, I would say would be a good idea is like and this is what I used to do, and it worked really well, is like after each chapter, you just kind of write all the important information from that, maybe like a one piece of paper, front and back, write small, get everything on there, do some highlighting to separate stuff, whatever you have to do. And then that's your study guide for that chapter. So, by the time the exam comes around, you have study guides for each chapter, and then bam, you just go through them however many times you have to get it down. Maybe there's some calculations you need to do. You also do those on the side, whatever. There's a lot of graphs you need to know. Maybe you draw those, a certain amount of times as well. But if you have it all in one place, it's a lot easier to sort of manage versus like, all these notes and book and lectures and all the information is everywhere. And then it's kind of hard to kind of focus on, okay, what should I be focusing on right now in my limited time so I can do well in the exams and prove that I'm a smart person, etc. Not that you're not smart if you do bad in a class like this. You're all very smart people, but in the world we live in, like, these things matter as far as defining our value to the rest of society. So, grades and degrees and whatnot, they're important. So you should put some value on that and do your best to try to have the best record possible so people will give you opportunities and all of this will pay off for you. Alrighty, let's jump into the material then. So we're gonna, I think we're covering all of Chapter 2 today. So Chapter 1 we covered. It was just, the basic principles that kind of underlie the logic and approach of economics. So make sure you know the terminology from that chapter as well as like the principles, what they mean. You don't have to memorize them. I would never ask you to list them. But like if I give you an example of something, you should be able to tell me like within what principle it falls if I give you like a multiple choice or something, that sort of thing. All right, let's jump into Chapter 2. Chapter 2 takes us further, not just establishing the basic ideas that we use, but like the basic tools that we use in economics, which defines our approach, and that is economic models. And the main economic models we're going to look at, or model and its extension, has to do with trade-offs and trade. So we'll focus on some important examples of models, 3 in particular. The first one is going to be the production possibility frontier. The second one is the comparative advantage model, and then finally the circular flow model. Don't worry, it'll all be explained to you when we get to it. And then just a brief word about using models, the fact that we do use models, simplifications of reality to study particular economic phenomena, be it an individual market. How are things working out in the iPhone market, in the smartphone market, versus like a particular industry? How are things working in like industries related to technology, and then the economy as a whole? How is the economy as a whole functioning? So different models explain different parts of the economy, and in order to study any given part, you have to simplify. You have to make assumptions about like the world that we are working in within the model, so that we can actually say something about reality versus just say, oh, it's too complicated, we can't explain it all. But if we say, well, we're going to say all these other things aren't important right now, we're just going to say, let's say for the price of a good, we're going to say that's the one thing that's going to affect the quantity demanded of the good, versus also saying, well, people's incomes also play into it, and like the price of related goods also play into it. If we just say, well, let's not complicate it, let's just look at the price of a good in relation to how much people are willing to buy, then that simplifies the relationship, and we can then understand that one thing. Obviously, you need a lot of models to explain a lot of different things that are related, that are important to economics. And so we're going to go through a lot of different models in this class, and that's where the challenge comes in. Is like you're gonna be presented a model and you're gonna get it, but then you're gonna be presented another model, you're gonna get that one, and then another one, you're gonna get that one. But then over time, they mount up, and by the time you're at the 5th or whatever model, then it's like, okay, well, I got to remember the stuff I already covered, but I got to learn the new stuff. And that's why it's important for you to, as we are covering things, like if you're not quite getting it in class, because you're not always going to get things in classes like this on your first pass. It's going to take you maybe your second pass or your third pass, where you go home and read the book or whatever. Whatever your approach is, whether it be like really getting stuff in class or getting stuff on your own at home, or a mixture thereof, you should try to understand everything that's covered like within a particular week that week, right? So like by the weekend, you've covered a bunch of stuff in this class, you've covered a bunch of stuff in your history class, your English class, all the other classes. Make sure that you're not leaving things uncertain for yourself, because the worst thing you can do is try to learn things for the first time right before an exam. You want to learn stuff before the exam. Yeah, you might not have it down perfectly. You might not be able to tell me exactly what everything we cover in this class is and how it works by the time the week before the exam comes around. But at one point during that period, you got it. And even though you might have forgotten it, it'll be easy for you to kind of just like go over it again and like, okay, yeah, okay, I get this. Okay, quick, I get it, I got it, because I had already gotten it before. Versus like, I've got to read 10 pages and really figure something out on top of like, 8 other chapters I have to cover. Like that's when things become a problem. So the approach here is so important. So be mindful of that and try to, just try to have that down the most possible, and stay on it like every single day. Don't, and if you miss a day or something happens and it throws you off, jump right back onto that horse. Get that momentum going once again as soon as you possibly can. Don't let a week go by or 3 weeks go by, because that's when it becomes bad. All right, Chapter 2, Economic Models, Trade-Offs and Trade. So we're going to learn why models play a crucial role in economics. We're going to talk about two simple but important models called the production possibility frontier and comparative advantage. They are related. And then finally, we'll talk about a brief schematic. A schematic diagram is just like a visual representation of a system. The schematic representation of the economy is called the circular flow diagram, and I'll briefly touch upon that one. I'll talk about this issue between what's called positive and normative economics. I'll define them when I get to it. And just briefly discuss why economists agree and sometimes disagree. And ultimately has to do with the fact that we simplify reality, and the simplifications that we make in studying whatever we're looking to study. People can say, well, that's too simple, or like I have a different set of simplifications that would maybe work better. So that's where like the debate and the conflict comes into play. Alrighty. Models in economics, some important examples. So a model is a simplified representation of a real situation that's used to better understand real life situations. Scientists who study the universe have models, right? They have the model of the solar system. They have models of galaxies, of the universe. You may have seen a model of an atom or the DNA double helix, right? These are sort of more tangible ways of understanding complex things. They don't necessarily capture all the complexity, but they capture enough that you're able to explain the nature of what you're studying. So models are also used by economists to better understand reality. Economic models attempt to simulate the workings of the economy, but the economy is a complicated system, right? A lot of people are involved in the economy, and there's what are called animal spirits involved, which is like the animal side of people that sometimes leads us to make decisions that aren't necessarily completely logical, and therefore you can't predict. So behavior of people can be erratic, and because of that, it can become difficult to say, well, the economy worked exactly as we predicted to. A model simplicity, though, allows economists to study the effect of changing just one part of the model. And so, again, you can just study one thing, like the price of a good in relation to how much of that good people are willing to buy. Every other part of the model is held constant. So in that relationship, again, we hold the income of people constant. We hold the price of related goods constant, etc. All right, so this whole thing of keeping things constant, it falls under the category of other things equal. It's an assumption we make, again, in models to simplify the model so we can study like particular relationships. So all other relevant factors remain unchanged. Ceteris paribus is like the Latin way of saying it. This is obviously something that's been used for centuries, this concept of holding other things constant, all other things equal assumption. All right, so we try to treat economics as close to a laboratory science as possible, with only one variable allowed to change at a time. But unlike other sciences where you have, like biology, where you can simulate certain parts of like the biological world within a laboratory, we can't have a miniature version of like people interacting in markets like in a laboratory. It's not possible. So again, you can't always find or create a small scale version of the whole economy. Sometimes situations will present themselves that are like kind of natural experiments where you have like one country doing something completely different from another country in the way they're approaching their economy. And then that can give us almost like an laboratory type experiment that can yield results about like, changing conditions in an economy. But again, like that's not something you can simulate. You can't set out to do that. And if you do that, that's cruel. Like you're basically playing with people's lives. Yeah, it's sort of it's an approach we want to take in our science like they do in other sciences, but obviously complicated by the fact we're dealing with people. So for many purposes in economics, the most effective form of economic modeling is the construction of thought experiments, simplified hypothetical versions of real life situations where we just say, all right, there's these things that are interacting with each other. Let's put a magnifying glass on those things. Let's add some of the characteristics we know inform the way those things behave, and then see what kind of intuitive results we can get from like this sort of exploration of how these things work without ever having to actually go into the world and study them directly. Yeah. So if you're talking about like, let's say the amount of iPhones that people are willing to buy, you can say, well, the price would change, right? Like you can have a price in one location versus a price in another location, and that'll change the amount people are willing to buy. And then we can say, well, we'll hold income constant. So we'll only study people that make a certain range of income so that we know that that's not affecting how much they're buying. All right, so example, an economist, again, might consider a consumer who's buying a CD and ask, what would happen if the price of a CD fell? CDs are these plastic discs that used to hold music. You can find them in museums. I know everything's digital now, but hey, the book used that example, so I'm using it. Economists use the model of consumer demand to answer the question, again, what would happen if the price of CDs fell? So it allows the price of a product to change to consider what happens to quantity demanded. So this simple thought experiment holds some other important factors constant. Like I mentioned earlier, consumer incomes don't change. Consumer preferences for CDs don't change. So we assume that those that are buying the CDs aren't, on just the flip of a coin saying, oh, well, I'm just deciding not to like CDs anymore. No, we assume people like CDs. So the only thing that's affecting their willingness to buy the CD is the price. The price of other goods didn't change either. So we assume that like the price of a CD player remains constant. See, the example shows that it's often possible to describe and analyze a useful economic model in plain English to tell a story. So what it highlights is one approach we take in economics to studying economics, and that is just using words to describe a situation we're interested in. It was the approach that was taken for centuries before mathematicians started like getting into our field and adding some of the concepts that were used in other fields like physics to kind of get us moving forward. I don't want to say like progress because we had already made a lot of progress, but like kind of take us in an interesting kind of parallel direction to like where the theory had gone, where everything that we had already come up with in words like can now be mirrored in equations, but then that did wind up progressing it because once computers were introduced, we were able to compute things a lot more powerfully than we were before, which then allowed us to understand certain more complicated relationships in ways that we couldn't before because we just didn't have the time to do the kind of computations that computers can do. So again, one way that we analyze things is just by talking about them, thinking about them via words. Since much of economics involves changes in numerical values, though, using some mathematics helps to clarify economic issues. So we'll consider three important models used by economists here to kind of highlight the nature of the approach, be it with words or with math. So the first one is the production possibility frontier. It's a model that helps economists think about the trade-offs that every economy faces. I'll show you what that is in a second. Another is the model of comparative advantage that actually uses the model of the production possibility frontier. So the comparative advantage model is a model that clarifies the principle of gains from trade, one of the principles we talked about in chapter 1, where we said that it makes sense for people to trade versus trying to just produce everything on their own. So trade both between individuals and between countries is what it is meant to study. And then the circular flow diagram is a schematic visual representation that helps us understand how flows of money, goods, and services are channeled throughout the economy. So we're going to make use of graphs to represent mathematical relationships in this class. If you're a little bit rusty on your ability to kind of read graphs, or maybe you just never really came to a solid understanding about it, Chapter 2's appendix is a pretty detailed sort of it just highlights the basic, most important aspects of graphs that you need to understand or to understand the graphs in this course. So even if you have covered graphs before and you know you're good at them, just kind of flip through Chapter 2's appendix. Make sure that you have all those concepts down so that you can understand what I'm talking about with respect to graphs. So graphs obviously are representations of mathematical equations. So that's where the math comes in, and then again, the language of math is used in two ways in our approach, both via graphs, just to kind of provide the basic intuition of the relationships and how they work. So visual representations tend to simplify how those things work, and then of course via equations, where with equations, you have the logic of a system that you're studying that is as clear as it possibly can be. If the math works, then the system must work that way. Now, whether or not those equations are the right equations for the system or not is what people tend to debate sometimes. But once you have those equations down, the logic that is in those equations is solid. It's not something you can call into question. And so it is the third approach that we take. So equations, graphs, and words are basically the three languages we use in economics to describe what we're looking at any particular time. So yeah, graphs play an important role throughout the course. If you don't understand how graphs work too well, then you're not going to do well in the course, because we're going to be looking at a lot of graphs, and you're going to need to know how they work. So again, Chapter 2's appendix. Spend some time on it. Really, if you're rusty on this stuff, really spend some time on it. Sit down, take notes on it. Just be very sort of focused on the concepts in that part of the book, because it's going to help you a lot during the semester. Not just in this class, though, in other classes as well. Graphs are just a standard way of communicating information, and you're going to see it in any discipline. So I suggest you again refresh your memory on how graphs work. It's in the appendix to Chapter 2, and it provides a brief introduction to use of graphs in econ. All right, let's talk about the first model, the production possibility frontier. The first principle of economics introduced in Chapter 1 is that resources are scarce, and as a result, an economy faces trade-offs, and that's what the production possibility frontier is meant to embody. So it illustrates the trade-offs facing an economy that produces only two goods. So we simplify the world and we say, let us assume that there's only two things being produced in this world, and that the people within it live in this world and are making choices about what to produce, either one thing or the other thing. So it shows the maximum quantity of one good that can be produced for any given quantity produced of the other good. So the PPF, the production possibility frontier, which I'll refer to as the PPF from this point forward, is a diagram that shows the combination of two goods that are possible for a society to produce at full employment. So full employment is a situation where the economy is using all its resources to produce. So if there's a ton of people that are willing to work, everybody's working. If there's a bunch of factories and machines that can be used to produce, they're being used. That's what full employment means. The PPF model can be used to answer questions like, how much can we produce? What will it cost to change our mix of production? If we're deciding, I'd rather produce less of this and more of this other thing. Does it make sense to import a good from somewhere else, or just to produce it yourself? All right, so this is an example of a production possibility frontier in a world in which only coconuts and only fish are produced. So in this world, that's all that exists. The people within this economy have to decide, are we going to produce just coconuts? Are we going to produce just fish? Or are we going to produce combinations of the two? So again, the model simplifies reality by looking at just one economy and assuming it can produce different amounts of just these two goods. The model assumes that the economy has a given amount of resources with which to work. So when we're talking about this simplified model, we're not thinking about, well, what, is there something within the model that can help us to maybe increase the amount of people that can work and therefore produce more? Is there something within the model that can help us understand how we can maybe get more machines and be able to produce more? No. We assume if we're looking at a line or a version of a production possibility frontier, it can be a line, and we'll look at a different version in a second, then we assume that the resources that it takes to produce are in existence and we cannot adjust them. We can make assumptions about adjusting them later, which we will, but when we're just looking at a production possibility frontier, there's a certain amount of resources that exist and they are not changing to produce with. It also assumes that a given level of technology, where technology means the ability to make use of the resources. So again, like the level at which our technology has advanced to be able to produce either coconuts or fish is what it is. Like nobody's going to come in and in this very simple world and say, oh, I've got a new way of creating fish that's going to double our production. Like that's not going to happen in this simplified world that we're working in, unless we assume it to happen. For now, we say no. So based on the assumptions, the economy can produce a number of different combinations of coconut and fish. So the number 30 over here represents the quantity of coconuts that the economy could produce if it only used all its resources to produce coconuts. So that point there, again, represents 30 coconuts. And again, so fish are on the x-axis and coconuts are on the y-axis. So, and this line is the production possibility frontier. So at this point, the economy is using all of its resources to produce 30 coconuts, and because it's doing that, it can't produce any fish. So it's producing 0 fish and 30 coconuts. The number 40 over here represents the quantity of fish the economy could produce if it used all of its resources to just produce fish. So instead of just producing coconuts, in which it could, given its technology and its productive resources, produce a total of 30 fish, it chooses to use all of its resources to just produce coconuts. And based on this production possibility frontier, we know that if they do that, they can produce a maximum of 40 fish. Let's say the economy wanted to produce some of both goods, though. They wanted to produce a mix of both goods. Then any point along the line will represent a combination of the two goods that the economy can produce if it, again, is using all of its productive resources. So if the economy wanted some of both goods, it could produce combinations like A or B. All these combinations are points on the production possibility frontier, so the economy is using all its productive resources. So any point on the line represents points that are mixes of the two goods the economy can produce in which all resources are being used. If the economy is producing at points within the line, then it is not using all of its productive resources. So along the line, which is the production possibility frontier, all resources are being used. So the trade-off that the economy it has to face as a result of having a certain amount of resources to produce with and having a choice of either to produce fish or coconuts is embodied in each point. So suppose the economy is producing initially, the economy just like they knew that they could create fish, but they really love coconuts. So for a long time, all they produced was coconuts. They produced 30 coconuts and 0 fish. But let's say at some point, new generation came in. They're like, we kind of like fish. We don't want just coconuts. We can produce fish, so we should produce some fish. So to produce fish, resources must be moved from the production of coconuts to the production of fish. So starting from this point here, let's say the economy decided we're going to produce 20 fish. And so therefore, they're going to move down along the production possibility frontier to point A, in which 20 fish are being produced, and in this case, 15 coconuts. So In order to produce 20 fish, the economy had to give up the production of 15 coconuts. This trade-off that the economy had to make in order to create fish represents the opportunity cost of producing fish. It's what you must give up in order to get something else. We talked about that as one of the principles in chapter 1. The true cost of anything is the opportunity cost. It's not just the explicit cost, but also the implicit cost. It's not just the actual cost that you pay for to produce fish, like the labor and like the machines you have to pay for, whatever, but it's also the implicit cost. You had to give up the production of coconuts, in this case 15 units. So in this simplified reality, those 15 fish, because we're not talking about the cost of labor and all this other stuff, is the cost. So it is the opportunity cost. What you must give up, the 15 coconuts is the cost of producing 20 fish. All right, so every point along the PPF, the production possibility frontier, again, representing varying combinations of the two goods that can be produced within the simple economy that's using all of its resources to produce. All those points have one thing in common, and that is what we call efficiency. So since you can only produce more of one good by producing less of another, there are no mixed opportunities. So you, at any given point, the only way you could wind up producing more of one good is to produce less of another good. And so because of that, there is a type of efficiency that has been achieved. I'll talk more about efficiency in a second. If an economy is producing at any point on its production possibility frontier, we say that the economy is efficient in production. I'll talk about in a second why I specify production here. So if we can contrast that with other points. So again, the points along the PPF, the actual line, represent points where production is efficient. And also represents points that are feasible, meaning that they are attainable. You can produce that amount. Points within the production possibility frontier, within the triangle, are feasible, but they are not efficient. We can produce this amount, but like if we're producing at point C and we're only producing 9 coconuts and 20 fish, we know that we could be producing either more fish, up to 28 with that 9, or with the 9 coconuts, or we can be producing 15 coconuts with the 20 fish. And so because of that, we're not using all of our productive resources any point within the production possibility frontier, and therefore those points are not efficient in production. They are feasible because we can produce those amounts, but they are not efficient in production. Again, the economy could produce C, meaning that it's feasible, but the economy could do better than C. The combination at C is not efficient. So all points under the curve are feasible but not efficient. All points above the curve are not feasible. So if you have this point up here, D, in which a huge amount of both goods is being produced, yeah, that's great, but we can't produce them given what we have to produce. So it is not feasible to produce that combination of coconuts and fish. And then all points on the curve are feasible and efficient in production. But that's not the whole story about efficiency. The economy as a whole has to be efficient in allocation as well, which means that out of all the combinations on the PPF, it has to choose the one that makes consumers as well off as possible. It has to also produce a combination of goods that the people actually want produced. So it has to be efficient in allocation. And when an economy is both efficient in allocation and efficient in production, we say that we have achieved efficiency for the economy as a whole. And again, it requires both efficiency in production and efficiency in allocation. To be efficient, an economy must produce as much of each good as it can, given the production of other goods, and it must also produce the mix of goods that people want to consume. All right, the last assumption made here is that the PPF is a straight line with a constant slope. So we are also assuming that the PPF is just a line. we can represent the PPF, the production possibility frontier, with a different shape, and I will in a second to demonstrate what that means. But here we are assuming that it's just a straight line with a constant slope. What this means, what the line tells us, representing the PPF as a line, what that tells us is that the opportunity cost of coconut for fish and vice versa, the opportunity cost of fish for coconut, is constant, is the same regardless of the point of efficient production. So anywhere along this point, the trade-off is the same. So one fish can be traded for however many coconuts, regardless of where you are on this line. So let's say we're at point C, again, only producing coconuts, and we want to go to point A. So we're going to produce 20 fish. So the opportunity cost of 20 fish is 15 coconuts. So how we can represent that mathematically. So again, we're trying to figure out the opportunity cost of fish. The opportunity cost of fish will be in coconuts. So it's going to be a ratio of the amount of coconuts you're giving up to the amount of fish you're gaining. So if you're looking at the cost of one good, in this case fish, you're going to put the good that it's being valued at in terms of opportunity cost in the numerator, and then the value of the good you're looking to value the cost of in the denominator. So the opportunity cost of fish is going to be 15 coconuts over 20 fish, and we can simplify that. It's got a common factor of 5. So we can factor out 5. 5 goes into 15 3 times. 5 goes into 24 times. It goes down to 3/4, or in decimal form, 0.75 coconuts. So what this tells us is that the opportunity cost at this point of one fish is equal to 0.75 coconuts. But let's say we went from point A to point B. Let's say the economy was at this point producing 15 coconuts and 20 fish, and it decides, okay, we want more fish. To get more fish, we have to produce less coconuts. So the opportunity cost of producing, so here we're going to produce 28 fish in total, but we're only gaining 8, right? Going from 20 to 28. So the opportunity cost of those 8 fish is going to be the 6 extra coconuts we have to give up. We were at 15 before, now we can only produce 9. So 15 minus 9 is 6. We're looking again for the opportunity cost of fish, which is going to be measured in coconuts. So coconuts goes in the numerator. 6 over 8. 2 is a common factor there. You can factor that out. You're left with 3/4, which is again 0.75 coconuts. So the opportunity cost of fish in terms of coconuts has not changed along the production possibility frontier, and that is exactly because we have chosen the production possibility frontier to be a straight line. The opportunity cost is constant along the production possibility frontier. Yeah. Where did I get these numbers from? So we're going from this point A to point B. To go from point A to point B, we want to produce 8 more fish, but we have to give up 6 coconuts from 15 to 9. So 6 over 8. You put the cost of fish in coconuts at the top, and then the amount of fish you're going to produce at the bottom. These are calculations I would expect you to make. We'll go through another example in a second. I will allow calculators, of course, simple calculators, scientific calculators, not graphing calculators, and not your phones on exams. I'll talk about that again when we get closer to the exam. All right, so again, the production possibility frontier with a straight line has a constant opportunity cost. Let's say we were to complicate this a little bit more to capture a little bit more complexity, because reality is more complex than that. If we do that, we could represent the production possibility frontier as a curved line. So economists believe that in reality that opportunity costs are actually increasing. The more you produce of something, the more of something else you have to give up for it. So a curved PPF captures that complexity. We characterize it as being bowed out from the origin. So that's what it kind of looks like, a bow, that you would shoot arrows with. When it has this shape, it's bowed out from the origin, also known as concave. So we can examine how this opportunity cost is increasing by just kind of going along the PPF as we did with the straight line PPF. So let's say we were at that initial point of producing just coconuts 30, and we decide, oh well, we want to actually have 20 fish that we're creating. So Because the PPF looks like this, as we move from this point to point A, we're only giving up 5 coconuts, and we're producing 20 fish. So the opportunity cost of fish from that initial point to point A is going to be the amount of coconuts we're giving up, which is 5, over the amount of fish we're getting, which is 20. So 5 over 20. 5 is a common factor there. 1 over 4, 1/4 is equal to 0.25 in decimals. So going from 30 at that point to point A, the opportunity cost of fish on average along this range is 0.25 coconuts. So for each fish you produce, you have to give up producing 1/4 coconuts, given your productive resources and your technology, and the fact that you're willing to use all of it to produce efficiently, meaning you're producing on the PPF, the production possibility frontier. Let's say the economy was like, we're kind of tired of coconuts. We actually just want to produce fish. So to go from point A to this point here where you're only producing fish, again, 40 being the most you can produce, we see that the opportunity cost increases of producing 20 fish. So initially, we increased our production of fish from 0 to 20, and now we're producing 20 more fish. So again, we are increasing our production by 20. But to produce 20 fish, in this case, we have to give up the difference between 25 and 0, which is 25 coconuts, right? So we're giving up 25 coconuts to produce 20 fish over this range here. So the opportunity cost of fish, thus, is now going to be that 25 over 20, right? 5 being the common factor. 5 goes into 25 5 times. 5 goes into 24 times. So that's 5/4. So over this range here, in order to produce an extra fish, you have to give up 1.25 coconuts per fish. So the opportunity cost has increased from 1/4 coconut to 1 1/4 coconuts. So as more of a good is produced, its opportunity cost rises, and this is the reason why we would include this assumption and make the PPF more complex, is because well-suited inputs are used up and less adaptable inputs must be used instead. So, the amount, like you have certain people that maybe grew up their entire lives knowing how to create coconuts, and certain machines that were used just to create coconuts. The economy then is saying, no, we just want to create fish. So all those people are now going to have to be retrained. They're not going to be that fast at producing fish because they grew up learning how to create coconuts. Machines, technology designed to produce fish now has to be changed, repurposed to create fish. It's not going to be that great. It's going to take more time. So the opportunity cost of producing those 20 more fish is now going to be greater because you have to dedicate a lot more resources just to be able to produce those extra 20 fish that weren't intended to produce fish. So that's what the curved line sort of is meant to capture, that extra complexity of life where opportunity costs do increase. So again, this model has a couple of purposes. One, to highlight the nature of models, and two, to understand what the model is actually telling us. So you have to be able to understand what the opportunity cost is, what it means to have a straight line versus a curved line, and be able to calculate those opportunity costs. The PPF can also be used to demonstrate the concept of economic growth. So we talked about the concept of economic growth in Chapter 1, the increasing ability of the economy to produce, right? So if you go back to like the early 1800s, before the first industrial revolution, we hadn't automated anything yet. Everything was created by hand, like it was difficult to create a lot of things. We created as much as we could. Then all of a sudden, the cotton gin was invented, and then the internal combustible engine, steel, and then finally the last industrial revolution that occurred over the last 30 years, the digital revolution. All these things helped us to produce more per unit of time. And so because of that, we have an increased capacity to produce in our economy, right? So we can represent that economic growth in a PPF by having it shift out. So economic growth, again, is an increase in what the economy can produce. And we can represent that by shifting the entire PPF out if indeed we're talking about growth, right? If we're talking about the economy contracting, meaning it's producing less, then the PPF would shift in. So the economy can now produce more of everything. So let's say before it could only produce 20, if it wanted to produce 25 coconuts, it could only produce 20 fish. Now, for 25 coconuts on the PPF, it can produce almost like 40 fish, right? So that's, again, representative of the fact that the economy can now produce more of everything. That means that from here to here, one of two things changed. Either our productive resources increase, so there's more people that can be used to produce, more machines and buildings are available to produce because of maybe a lot of investment that's used to create those things. Or technology has improved, like in the Industrial Revolution and all the industrial revolutions we've had, like the improved technology has allowed us to produce more of everything. And so that's what this the shifting of the line represents. If we're looking at one PPF that's not shifting out, then that PPF reflects the fact that our technology and our productive inputs are fixed. Those are not changing. So again, comparing points A and point E, there's more of both goods that can be produced. So we say the PPF has shifted outward, increasing the possible production of both goods. As I already mentioned, there are essentially two sources of economic growth. One is an increase in the economy's factors of production. Factors of production are resources used to produce goods and services. Economists usually refer to the term factor of production to refer to a resource that's not used up in production. Land is a resource provided by nature. Labor is the economy's pool of workers. Physical capital refers to created resources like machines and buildings. Human capital refers to the educational achievements and skills of the labor force. So all of you here, you are increasing your human capital by being in college and learning about a variety of things that will ultimately make you more prepared to, go out in the world and be more adaptable to a variety of industries. So you are increasing your human capital, which is increasing the capacity of the economy to produce. The other source of economic growth is technological progress, like I mentioned, the industrial revolutions. So technology is the technical means for the production of goods and services. Yeah.
What's the difference from technological progress and physical capital?
So physical capital is just like what you have, right? Like, so I've got a computer, I've got, I've got a plow that can farm. I'm not a farmer, so anyway. So yeah, you've got these things, right? Those are your physical capital. Then somebody comes along and says, I can automate this plow. I can combine your computer with your plow and make it work on its own and work a lot faster than it normally would. So that's the technology being improved. You got that? Sure. Feel free to ask questions anytime. There's no such thing as a dumb question. Like, if you have a question, ask it. Because if you're not asking it, you're not going to get the answer. All right, so understanding the production possibility curve is essential for understanding the next model of comparative advantage. Comparative advantage uses the production possibility frontier to examine the benefits of trade. So the comparative advantage model considers two producers, each of which produces the same two goods. In this model, we compare the two production possibility frontiers to see which producer can produce which good cheaper. Cheaper meaning at a lower cost. Costs in this class are always opportunity costs, so at lower opportunity costs than the other. The philosophical result of the idea of comparative advantage is that it makes sense to produce the things that you're especially good at producing and buy everything else from others, right? The tall dude should specialize in picking apples, whereas the short dude should specialize in picking strawberries, and then they can trade. A country or individual has a comparative advantage in producing a good or service if its opportunity cost of producing the good or service is lower than that of the other country or individual. So that's how we define comparative advantage. You have a comparative advantage if you have a lower opportunity cost than somebody else in doing whatever you do. All right, so let's go through an example to understand this model of comparative advantage, and we'll use the PPF to identify it. So suppose you have two countries of Krugmania and Wellsia, and they produce only two things. They produce apples and they produce pantyhose. If Krugmania only produces apples, then they can make 100 units of apples. If they only produce pantyhose, then they can make 150 units of pantyhose. As far as like the graph of this country's PPF goes, what is this? What does this 100 units of apples signify? If apples are on the y-axis, let's say. If they only produce apples, they can make 100 units of apples. Right? So what does that look, how does that translate to the graph? Right, so how does that look graphically? If apples are on the y-axis, let's say. It's the highest point of the line. It's the y-intercept. It's where the line hits the axis, right? So that's what it's telling us. It's telling us those 2 points, right, that can be used to connect the line to establish the PPF on a graph, right? So if Krugmania only produces apples, they make 100 units of apples. If they only produce pantyhose, they make 150 units of pantyhose. If Wellsia only produces apples, they produce 300 units of apples. If they only produce pantyhose, they produce 150 units of pantyhose. Assuming constant opportunity cost. So what does that mean for the graph? It's a straight line, right? Exactly. So we're going to look at a simplified version of these PPFs. So let's graph them here. Here's the Krugmania PPF. We're going to have apples on the y-axis, pantyhose on the x-axis. So Krugmania, if it only produced apples, would produce 100. Only produces pantyhose, it produced 150. Or it could produce a combination of the two along this line with constant opportunity cost along it. Wellsia, similar. Only produced pantyhose, it could produce 150. Only produced apples, it could produce 300. Or it could produce a combination of the two along its PPF, which has a different slope. You can see it's steeper. This one's flatter. That means their opportunity cost between the two countries will be different. Along Wellsia's line, its opportunity cost is constant. Along Krugmania's line, its opportunity cost is constant. So eyeballing the graphs also allows us to assess which country has another sort of advantage, not just comparative advantage, which is what we're looking at, but what's called the absolute advantage. So a country has this advantage in producing a good or service if the country can produce more output per worker than other countries. So let's say we compare both countries and we see, Krugmania can produce 100 apples and Wellsia can produce 300 apples if they each use all their productive resources just to produce apples. Because Wellsia can produce 300, which is more than 100, Wellsia has an absolute advantage in apple production. We can determine which country, again, has the absolute advantage by looking at the intercepts of the PPF graph. Again, the intercepts are the points at which the graphs, the PPFs, hit the axes. So to determine which country has an absolute advantage in producing apples, as I said, you compare the intercepts. So Wellsia 300, apples for Krugmania is 100. So in this case, Wellsia has an absolute advantage in producing apples because 300 is greater than 100. Similarly, neither country has an absolute advantage in producing pantyhose because they can each produce 150 pantyhose if they both just use all their resources to produce pantyhose. All right, we'll next determine which country has a comparative advantage in producing each good. So remember, we're looking at which country has the lowest opportunity cost in producing a good. So we'll focus on one good and then the other, and then we'll compare opportunity costs and see whoever has the lowest one has the comparative advantage in producing that good. Which one has to give up the least to produce that good? Whichever one has that has the comparative advantage. All right, so we're going to look at apple opportunity cost. So for Krugmania, we're going to look at the apple opportunity cost. The best way to measure opportunity cost when you have these straight line PPFs is to look at the intercepts. So if we're going to look at the opportunity cost of apples, we're going to look at that in terms of pantyhose. So pantyhose will be on the numerator, and the denominator tells us the amount they have to give up for that. So in order to produce, so we're talking about apple opportunity cost. In order to produce 100 apples, the Krugmania needs to give up 150 pantyhose. So we have here. So we're looking at, I'm getting confused here for some reason. So the opportunity cost of apples is going to be in pantyhose. Yes. Okay. All right. Sorry. All right. Got it. So the opportunity cost of apples is going to be in pantyhose. So in order to produce 100 apples, we're going to give up 150 pantyhose. So the cost of apples is going to be in pantyhose. So you have 150 over 100. The common factor there is 50. So 50 goes into 150 three times, goes into 100 twice. 3 over 2 is equal to 1.5 pantyhose. So for Krugmania to produce one apple, they have to give up 1.5 pantyhose. For Wellsia to produce 300 apples, it has to give up 150 pantyhose, right? So it's going to be 150 over 300, which is going to equal half a pantyhose. So who has the comparative advantage in producing apples? Wellsia, right? Why? Which is a lower what? Low opportunity cost. That's what defines a comparative advantage. Very good. So therefore, Wellsia has a low opportunity cost in producing apples, and therefore it has the comparative advantage in producing apples. All right, now let's look at pantyhose. So Krugmania, in order to produce 150 pantyhose, it has to give up 100 apples. So you put 150 over 100. Also, when you're looking at the production possibility frontier, if you've already calculated the opportunity cost, a simple shortcut is you take the reciprocal of what you already calculated to figure out the other opportunity cost. So you just switch the numerator and denominator. So apple opportunity cost was 150 over 100. Pantyhose opportunity cost is 100 over 150. It's the reciprocal. So 2/3 apples. So in order to produce one pantyhose, it has to give up 2/3 of an apple. That's for Krugmania. For Wellsia, it's going to be the reciprocal of their apple opportunity cost. For the pantyhose opportunity cost, so it's going to be 300 over 150. So it's going to be 2 apples. So who has a comparative advantage in producing pantyhose here? Krugmania. Why? Why? It has a lower opportunity cost. Very good. And therefore, it gives them what kind of advantage? Comparative advantage, exactly. So Krugmania has a low opportunity cost in producing pantyhose, 2/3. So Krugmania has a comparative advantage in producing pantyhose. All right, so we've established who has a comparative advantage. Next, we need to consider how Krugmania and Wellsia can benefit from this situation where they have different opportunity costs. Let's look at how they can achieve the gains from trade that we talked about, that the economy tends to help result in. So we're just assuming here that before they're trading, when they're just producing their own stuff, not thinking about what the other country can do for them, that they are consuming without trade, Krugmania, 50 apples and 75 pantyhose, and then Wellsia, consumption without trade, 150 apples and 75 pantyhose. They do their opportunity costs analysis. They figure out who has a comparative advantage, and whoever has a comparative advantage should just be producing that good, and then they should be trading. So similarly, without trade, Wellsia, again, we already know these numbers. Okay, so having different opportunity costs means that the countries can benefit from specialization and trade. The fact that they have different opportunity costs means that they can benefit from trade. So Krugmania has a lower opportunity cost in producing pantyhose. Krugmania should specialize in pantyhose production. Wellsia has a lower opportunity cost in producing apples. Wellsia should specialize in apple production. Yeah.
Consumption with trade, does that mean like it's just one of the options?
So we're not there yet, but it will be. Yeah. When we get to that, yeah, it'll be consumption with trade, and each of them will specialize in what they have a comparative advantage in. So then the two, so because they each have a comparative advantage and they can specialize, then they should, and then the two should trade in order for each to have some of both goods. So in order for both countries to voluntarily trade with each other, the trade must benefit them most. Must benefit them both, sorry. So again, we know Krugmania produces pantyhose and Wellsia should produce apples. The next step is for the countries to decide on the trading price. What should that price be? So Wellsia can produce apples at a cost of half a pantyhose. So Wellsia will produce apples, and we know that their opportunity cost is half a pantyhose. So they're going to give up half a pantyhose for every apple they produce. So it will want to receive at least half a pantyhose for each apple, or else it would want to do it itself, right? Wellesley wants to cover its cost of production. So half a pantyhose can be treated as the lowest price it will accept for each apple. Krugmania is happy to buy apples from Wellesley. Krugmania is going to produce pantyhose. In order to produce its own apples, if it were to do that, it has to give up 1.5 pantyhose, right? So Krugmania can always produce its own apples at a per apple cost of 1.5 pantyhose. So as long as it can pay less than that, then it'll be happy. It'll be benefiting from it. And as long as Wellesley gets more than half, then it'll be happy as well. So Krugmania will be happy if it can receive apples from Wellesley for a trading price of below 1.5 pantyhose per apple. So we've established a lower and an upper limit for what one apple will likely trade for, either half a pantyhose or 1.5 pantyhose. So this range that the good can potentially be traded for is what's called the terms of trade, the price range that makes trade mutually beneficial, right? If the price was less than 1/2, it wouldn't be beneficial to Wellesley. If it was more than 1.5 pantyhose, it wouldn't be beneficial to Krugmania. So in this case, it's above 1.5 pantyhose and below 1.5 pantyhose per apple. Assume that they had their officials like get together, figure out what's the best price, and they decide, well, let's just trade 1 for 1. 1 apple for 1 pantyhose. So we'll now examine consumption when the countries specialize and trade. So the figure shows an example of this scenario where the two have specialized and have decided to trade 75 apples for 75 pantyhose. So Krugmania was initially consuming without trade 50 apples and 75 pantyhose. But since they're trading 1 for 1 and Krugmania has a comparative advantage in pantyhose, it produced 150 pantyhose and no apples. It traded, in order to be able to consume the same amount of pantyhose, it traded 75 pantyhose for 75 apples. So it can still consume 75 pantyhose, but now it is able to consume at a point that's not feasible within its production possibility frontier. It's able to produce at this point here that represents consuming 75 apples and 75 pantyhose. Wellesley has a comparative advantage in apples. So it produces only apples, produces 300. Before, it was consuming 150 apples and 75 pantyhose. It wants to consume the same amount of pantyhose. So it gets that 75 pantyhose from Krugmania, trades 75 apples for it, so has to reduce the amount of apples it has from 300 to 225. So it winds up consuming with trade at this point, outside of its production possibility frontier. It's able to now consume many more apples, in this case 75 more than before, and the same amount of pantyhose. So specializing, again, Krugmania produces 150, Wellesley produces 300. Trading 75 for 75 leaves Wellesley with 225 apples to consume, which increases its apple consumption by 75. This is everything I just said. Similarly, Krugmania increases its apple consumption by 25. So comparative advantage exploited has led to gains from trade, right? Now everybody is able to consume more of everything because the people that have the least opportunity costs, the comparative advantage in producing, focus on that, specialize, trade with the other country, more of everything is produced, everybody gets to consume more. Trade is a good thing, Donald Trump. All right, so that's comparative advantage and PPF. Make sure you understand both models, how to calculate the things that we just calculated, how to establish who has a comparative advantage and why. Everything we just covered, you should understand. So a lot of what we'll do here is like go through models in fine detail like we did. And then I'll expect you to be able to like explain those models again or like reproduce them graphically or maybe do the same calculations that I do. So just keep that in mind. All right, the final model we'll look at is the circular flow model. Let's consider our third and final model for this section, the circular flow diagram. You don't have to memorize this diagram, just kind of understand what it is and understand like the flows. So the model illustrates the flows of money, goods, and services through the economy. The figure shows a simple circular flow diagram. In this case, in an economy in which there's only households, individuals that are families, whatever, and firms, companies that produce. A household consists of either individuals or a group of people that share their income. A firm is an organization, usually but not necessarily a corporation, that produces goods and services for sale and that employs members of households. Firms and households interact in two kinds of markets in this simple model that we're looking at. So in the market for goods and services, households buy goods and services they want from firms. In these factor markets, so factor markets represent the markets for the factors of production, right? Everything that we listed earlier, the things that you need to produce. Those things need to be bought and sold, right? Labor, your work needs to be sold by you to an employer who buys it. So factor markets deal with, again, firms buying the resources they need to produce goods and services. So transactions in the markets for goods and services produces a flow of goods and services to households and a return flow of money to firms, right? So the firms produce goods and services, households buy goods and services, pay for those goods and services with money, which is then given to the firms. Transactions in the factor markets is comprised of firms buying the resources that households sell. So households sell the factors of production to the firms, and the firms pay for those factors of production via money, and that is circulated back into the households. So trade in physical things such as goods, services, labor, and raw material flows in one direction, right? The yellow arrows. And then the money that they pay for these physical things flow in the opposite direction. Obviously, the economy is more complicated than this. If you take a macro course, you'll see a more complicated version of a circular flow diagram. There's different types of households we can talk about. Some households run their businesses out of the home, which complicate this model. Don't think about the complicated cases that lie outside of the simplified model we're talking about in terms of trying to understand the model. It's okay to understand that the world is more complicated than what we're talking about in our models. But when we're talking about our models, kind of just think within the model. We, again, like I mentioned, economists acknowledge that sometimes the simplifications aren't realistic, but the insights that we gain from them are legit. Like they do correlate well with what actually happens in the world in terms of explaining things, in terms of helping us to maybe predict the way things are going to work. And so we're happy with our models. We're always trying to improve them. That's what you do at the later academic levels. That's what I did in my PhD program. Sort of like it took me to the edge of where we're at in terms of understanding the economy with our models, and then sort of I learned how to myself, if I wanted to, like model any part of the economy so that I could then create my own models that might be better, and that's something I'll do throughout my lifetime. Brief note on using models. Economic analysis has two key roles. The analysis tries to answer questions about the way the world works, which have definite right or wrong answers, and this is known as positive economics. In contrast, analysis that involves saying how the world should work is known as normative economics. So if I'm saying that you give a population of Californians an increase in their wage by $5, that will increase the overall output in the economy by $3 billion. That is a positive statement. I'm basically just looking at the conditions within the economy and I'm saying what they will result in. I'm not saying if that's a good or a bad thing. I'm just saying what's happening. Versus normative. I don't think it's good for us to give Californians a wage increase because this extra output is not worth the cost of paying the workers this much. That's a normative statement. That's me imposing my own ideas. By the way, those aren't my ideas, but that's me imposing my own ideas into the analysis. And it's important to understand the distinction between the two. Positive economics is about description. Normative economics is about prescription, what you think people should be doing, the economy should be working, what is good, what is bad, versus what is happening based on what I can observe. Positive economics occupies most of the time and effort of the economics profession. So that's what we focus on. We focus on just describing things and trying to capture as much complexity in simplicity as possible to be able to describe how things are working. Policymakers, people in Congress, people in state government, whatever, use our work to try to justify, their policy goals. And they ultimately wind up working, within like a normative economic sort of framework in which they impose their own ideas of what should happen. Again, we are not about what should happen. We're about what is happening. What can we observe is happening? If we can't observe something is happening, then we acknowledge that. And we say, well, we don't have enough information about this to make any kind of legitimate, positive observation about it. But it's important to understand that there are economists out there that will try to impose their own ideas and try to present that as truth. And those are the economists you need to be careful for. I'm not one of them, but they do exist. So models play a crucial role in almost all positive economics. The distinction between prescription and prediction is important as well. So again, you can say things should happen in this way. I think that this could be better. I think the situation could be better if we did give people a raise in their minimum wage. That's a normative description. Versus a prediction where I say, well, if we give people a certain amount of money, then over time, the amount of incomes in the economy will increase by this amount. That is a prediction. So positive economics often uses models that explain an aspect of the economy and is used to attempt to predict what the economy will do via a forecast. A forecast is a simple prediction of the future. It's done generally using statistics. So we'll take a model, we'll establish some relationships between variables, like we talked about here, and then we'll say, well, given what we know about the world in this model, we can use statistics to sort of figure out what some of these numbers actually look like in the real world, and then use our statistical model to say, well, if things remain the way they're going, then they'll likely wind up at this point, where this much output will increase or incomes will go up by this amount. So that's a forecast. Forecasts may seem like prescriptions since they tell you what will happen if policy were changed, but they don't tell you whether or not the result is good. And that's why they are not prescription, they are predictions. Economists often do engage in normative economics and give policy advice, as I mentioned. There are some economists that will give normative advice, and that's because we're also citizens and we have opinions. But like the ones that will do that and are responsible will be very clear about that versus those that will just try to claim that they are the authorities on a particular area and they should be listened to no matter what, and what they're saying is true. That's where the problem lies. Be careful for those people. Economists do have a reputation for disagreeing because, again, there are these simplicities in our models that, again, aren't realistic. And so when you have aspects of some tool that's meant to guide, let's say, policymakers on what they should do that are based on assumptions that aren't realistic, it's easy to get into debates over like whether those things should be there or not. So that's a lot of conflict does arise, but in the field over time, there's a consensus that's reached where it's like, well, we're able to say there's certain simplifying assumptions we're all okay with. And the majority of economic research and our approach is based on that. Economic modeling, as I mentioned, requires simplifying assumptions that can be contentious. In most cases, such disputes are eventually resolved. The most important point is that economic analysis is a method and not a set of conclusions. All right, folks, we are done with Chapter 2. Congratulations. I will open up Chapter 2's homework, and it will be due... Actually, wait, hold on. So anything that... Like, all the homeworks aren't going to be due till the middle of the third week because of the add drop period. But after that, things will be, like, within a week, okay? But this one won't be due till the middle of the third week. I will open it up later today for you to do if you're interested in doing it. Have a great couple of days. I'll see you on Thursday. If you have...